Awesome. Welcome to this video. So in this video we are going to be learning about sizing solar battery bank, which is very essential. Okay, so we are taking it step by step. Okay, first we have done our load analysis that helps us determine the size of our load in any given situations. So, and I said after that the first step to go through is to do your inverter sizing. After you have done your inverter sizing, which we have done, we have also determined like based on our load demand that 7.5 kVA inverter minimum can power the system. We have also decided that it's going to be like 48 volt system, which is very important, because these two information, I mean the voltage of that system is going to be required to be able to size your solar battery. Okay, now coming to battery, in this video I'm going to walk you through on how you can size your battery, how to understand battery capacity, and also the proper way to size different types of battery. Okay, so let's get started. First, to start with, what is the role of the battery in the solar system? So simply, the role of the battery in the solar system is to store energy for use when there is no solar or NEPA available, when there is no solar or grid available. That is the role of a solar battery. That is the role of the solar battery in the solar system. When there is no NEPA, when there is no grid electricity, okay, to power the home or charge the battery, and when there is no solar to power the home or charge the battery, now the battery will now be used to supply the loads in the house. Okay, so that is the role of the battery. So the battery actually is the what determines how long a solar system is going to last when there is no NEPA, when there is no grid. Okay, if your system is going to last for 3 hours, 4 hours, 5 hours, 6 hours, 7 hours, or 12 hours, it's going to be dependent on the battery and your sizing. So it's good we know this thing, because it's going to be very important. So if you are hoping to give people any amount of hours of light daily, okay, after sizing your inverter completely, making sure that you have an inverter that can power all their load, for you to achieve that goal of giving them a particular, for giving them light for a particular amount of hours, is going to be dependent on your battery. All right, so with that said, what are the key factors? Let's look at the key factors. Okay, the key factors that you need in sizing your solar battery. One of them is the daily energy use. Okay, this is why I told you earlier that we doing system sizing is something that has to be done process by process, step by step. You start with the load auditing, energy auditing or load assessment, then you do the batteries inverter sizing, then you now come down to the what is it called? You now come down to the battery sizing before you can now talk about solar panel and charge controller and all that. Okay, so you need your daily energy use, and when we did our load energy audit there, we got our daily energy use of about 12,000 plus. Okay, all the appliances that you are going to be powering times how many hours they are going to run, you get your daily energy use, right? So we have gotten that. We are going to work with that figure. So another thing you need to consider, factors you need to consider to size your battery is backup days. Okay, daily energy use is for 1 day, the energy you are going to use for 1 day. So in a situation whereby you are designing a system, they need the system to last for two days, that is 48 hours or 3 days and all that. You need that factor, because it's your battery that is going to take responsible of that. It's your battery that can make that possible. So you need to consider how many days you want to back up. Mostly and normally is always 1 hour, 1 day, I mean 24 hours. But put this into consideration: 1 day, the numbers of days you are going to be backing up the system. Okay, then also you need the types of battery. So the type of battery you use will determine, okay, the size and the quantity, because each battery has different characteristics, both charging and discharging, and also lifespan. So each battery have different characteristics. So that also is also very important. Okay, so with this noted, these are the things we need. And for us here, we have gotten our daily energy use. So we are going to use the data we come up with on the load analysis, on the energy auditing we did. We are going to use that, and our goal here is going to be for 1 day. So we are going to be calculating to back up load for 1 day. So on the battery type, I'm going to show you how to work around both lead acid battery or lithium battery, so that in any case, whatever type of battery you are working with, to be able to know how to go about doing your calculation properly. So with this said, let's get to understand some of these data or informations that can help us understand battery capacity very well. So one thing you need to note is that batteries are read in volts. Okay, so battery comes in different kinds of volts. Okay, when it comes to solar batteries and all that, it ranges from 12 volts to 120 volts and above. Okay, it can even come in higher than 120 volts. Okay, but other batteries normally comes in volts, but their voltage can be lower. It can be 1, 2, 3, 4. But when it comes to solar system, the minimum voltage of solar system mostly start from 12 volts. So you have a 12 volt system, you have 24 volt system, you have 48 volt system, you can have 96 volts and above, 120 volts. And when it comes to industrial solar system and all that, it can range to 200 and 400 volts as the case may be. Okay, but just know that batteries, if you really want to know the capacity of a solar system, you need the voltage of that battery. But just know that if you really want to know the capacity of a solar system and the battery, you need the voltage of that battery. Okay, so another thing you need to note about battery capacity again is watt hour. So watt hour is used to describe the energy that a battery can deliver. Okay, just like we have everything, like I said earlier or previous lessons, I told you that everything you're going to be working on solar, in terms of calculating your load, you're going to be working on watt hour, because that is the measurement for energy, electricity, energy and all that. And in our case it is. Now, since we are going to be sizing battery, we also need this watt hour. So it's all about the amount of energy that a battery can deliver. So a battery can be rated 12 volts. Okay, but what amount of energy can it deliver? So another thing again that will help you determine this also is the amps. So the amps of the battery talks about the capacity of the battery. Battery is actually measured in amps. So the amps of a battery talks about the capacity. So the amps there tells you the amount of amperage that a battery can deliver under 1 hour. Okay, that is what is used to measure battery capacity. So most times, most battery will come only in amps and voltage. But believe me, with these amps and voltage, you can determine the amount of energy that battery can deliver with formulas. Okay, so the most important thing is to note this, the amps and the voltage. Now, in terms of lithium battery, you hear 15 kilowatts, 5 kilowatts and all that. In that regards, they have already done the conversion to tell you the amount of energy that battery can deliver. But when you come across battery, you will never see the amount of energy. You will not see the rating in watts. You will not see the amount of energy the battery can deliver in watts. They can only give you the voltage and the amps, of which these two things can help you, okay, determine the watt hour that battery can deliver. Okay, so these are basic things. We are going to do all these things so that you see how it works. I'm going to walk you through the formulas you need to actually come up and calculate this thing properly, so you know how. So I'm putting it up to you here so that you understand the different data or information you need to determine the capacity of a battery. Okay, so with this said, let's look at battery energy charge and discharge. So how do battery draw power and how do battery gain power to charge? Okay, so you need to understand how it operates. So batteries are rated in amps, like I said earlier. So 1 amps on a battery, like when they say, let's say for example, an appliance is drawing 1 amps from the battery, what it means that, and let's say the battery is rated 100 amps, an appliance is drawing 1 amps from the battery. What that tells you that appliance is consuming 1 amps under 1 hour. That is, if that appliance should run for 1 hour, it's going to consume 1 amps. That is what it means. If the appliance should run for 1 hour, it's going to consume 1 amps. And if you do this calculation, it means that if that appliance is run on that battery that is 100 amps battery, so it's going to run for 100 hours. Okay, so let's take an example again. Let's say you have a 100 amps battery, okay, that is supplying load under 100 amps. Okay, you have a 100 battery, all the total load connected to that battery. Okay, because your load, all these things we check, your ACs, your fridge, your fan, your lighting point and all that. Okay, the energy they use, why is rated in watts also. The electrical energy also that flows on them also are also measured in amperage. Although in our calculation we focus on the watts. Okay, but then when it tries to draw power, when it comes to drawing power from batteries and all that, they also rate in amps. Okay, you need to understand it. This is just simple understanding you need to understand, and you'll be clear with all this and also how to go about these calculations. So in that regard, if you have a load of 100 amps running on 100 amps battery, okay, it simply means that that battery can only last for 1 hour. Okay, so let's take another example. If you have a 100 amps battery, okay, then you have a total load of 10 amps running on that battery. It simply tells you that battery can last for 10 hours. Okay, so these are just simply ways you get to understand how long your battery can last you based on amps rating, based on the amps. Okay, so another way to determine this now is for us to convert the amps to kilowatt. Then you measure it. If you have 2000 kilowatts of load, okay, running on the system, how many times after you have converted the battery to kilowatt, you can now also measure it on watt. So in a nutshell, what you need to understand here is that the runtime of your solar system always depend on your battery. Okay, it always depend on your battery. All right, so with this said, another thing you need to understand here is that these amps can be measured in milliamps. This for smaller measurement. So if this thing is not up to 1, if your amps is not up to 1, it's going to be measuring more like a milliamps, which is used to measure smaller batteries, the ones on phone, on smaller devices and all that. Okay, I also know that this is just the measurement for calculation purpose, though we are not going to be dealing with anything less than 1 amps. We are not going to be going down to mini amps. These are for smaller batteries, but just know that it is 1000 milliamps that make up 1 amps. Okay, so basically that is how you need to know. Now what you also need to note here is that this discharging of a thing, this is all about discharge. What I explained here is all about discharging of your battery. The same thing if you are charging. Okay, let's say you have 100 amps battery. So if you provide a charging situation whereby your charging system is giving up to 50 amps to charge the battery, it means that the battery is going to charge for 2 hours. Or let's say your system, your inverter or your solar panel is giving 10 amps. It tells you that the system is going to take 10 hours to charge. So it's all about discharging and charging. So you should also put that into consideration. So with this brief explanation about charging and discharging of your battery, let's look at the formula you need to size your battery. Okay, so when it comes to battery capacity, if you want to size your battery capacity, so we have a formula. So this is the formula to calculate battery capacity, which is the amps of the battery. So let's say for example they gave you you saw a battery, it says 5 kilowatts, 48 volts, and you are not given the amps of that battery. You don't know the amps of that battery. Let's say you want to know how to set up your charging amp so that you don't feed the battery an amp rate that is higher than its amp capacity, but the battery no labeling and anything. How do you get the amp of that battery, whereby the watt hour is given and the voltage is given? The formula is simple. You do the watt hour, which is the energy. Okay, let's say for example they gave you that is a 5000 watt hour, which is equivalent to 5 kilowatts, but they did not give you the amp, but they gave you the voltage. For you to get the amp of that battery, that watt hour, the energy they gave you, the watt hour they gave you, or the kilowatt hour they gave you, you divide it by the battery voltage. You'll be able to get the amp of that battery, the amperage of that battery. Okay, that is the formula. Now another formula, let's say for example they gave you have the battery amp. So how do you calculate the energy, which is how do you convert a battery to watt hour to know actually the amount of energy that can be drawn for it? In that case, it will be in a situation whereby they gave you the battery voltage, they also gave you the battery amp, but they did not give you the kilowatt hour. That is the energy of the battery, the energy amount of energy that can be drawn from the battery. So in that case, this is the formula you are going to use. So for you to get the watt hour of that battery capacity, you are going to do the battery amp. Remember, in this case they have to give you the battery amp. If not, you cannot do anything. So if you times the battery amp times the system voltage, you'll be able to get the energy that battery can deliver in kilowatt or in watt hour. So another scenario you might have is whereby they will give you all the information for you to calculate the battery voltage. In this case, they will have to give you the energy, the watt hour of the battery, the energy that battery can produce. They will also have to give you the amps of that battery for you to be able to calculate the voltage of the battery, okay, without being specified. So in that case, this is the formula. It's going to be, if you want to calculate the battery voltage, it's going to be the energy, okay, which is in watt hour or in kilowatt. Once they give you the energy in watt hour or kilowatt, then you divide it by the battery amps. So to provide you the battery amps also for you to be able to determine the voltage or the system voltage or the battery voltage, okay. So all things I'm talking about system voltage here is actually referring to the battery voltage, but just also know that this is going to also be the same voltage the system will maintain, the inverter and everything is going to maintain, okay. So this is the formula for you to, okay, calculate all aspects of battery to determine the right information or data you need to make calculations or predictions for your battery, okay. So on that ground, there are other things you need to pay attention to. There are other things you need to consider when sizing your battery, which is depth of discharge. Now, depth of discharge simply means batteries, how deep or how can they discharge when they are charged full, to how level can they discharge, okay. So a lot of battery don't discharge fully. A lot of battery is not that healthy for them to even discharge more than 50 or 30%. So you need to consider this. So different battery have different depths of discharge. In this case, there is a general number used for different batteries there. So for example, if you are working with lead acid batteries, these like dry cells, tubular batteries that use water and all that, the recommended depth of discharge is 50%, okay. So when you have that battery, even though the battery power can be 100, just take note that it can only discharge up to 50. So it's better you size it based on that 50, okay, because if you size it based on 100 and at the end of the day it's only 50% can discharge, you will have a shortage of energy in your system, okay. This is very important. And when it comes to lithium battery own is about 80%, so they discharge more. They do an in-depth discharge. Some company and brand promise of even discharging up to 100, 95, 90, which is amazing compared to lead acid batteries, okay. So you need to put this into these considerations. Depth of discharge, you have to calculate it with these figures. After you have gotten your numbers of batteries that you think that will power your system, you need to put into consideration 80% discharge minus 20%, okay, from whatever figures you have gotten, to really know what that battery is going to deliver. If it's a tubular battery, you minus 50% to really know what that battery is going to deliver when in use, okay. So all these informations are very, very important. So with all this now, if you understand all this to this extent, you will be able now to do your battery sizing. And here is a formula that you can use to size your battery, okay. You can do for battery size, if you want to ascertain capacity of battery that will be able to power a particular load demand for a particular hour, okay. Here is the formula. So the daily energy needed is equals to your daily load times backup, okay. You have to do daily load times backup. Daily load times backup, you'll be able to get amount of battery you need. So it's simple. On our own now, we have done our load analysis and we determined that our daily load was about 12,000 plus, and it's going to serve for 1 day, which is 12,000 plus times 1 day. That is our daily load on our own experiment, okay. In your own situation, it can be different depending on the size of the load or depending on the days they want the backup to extend, but generally 1 day is defaultly used, okay. So in our own case now, we have about 12,000 plus watts of load times 1 day. That is the size of battery we are looking for, okay. A battery that can produce up to 12,000 kilowatt hour a day. That is what we are looking for, okay. Then we'll apply our depth of discharge and all that. We need to make sure whatever we get, our battery, if we get a 15 kVA or 15 kilowatt, whatever size we get after our calculation, it must be to this amount, but with depth of discharge applied. So any size of battery we arrived here we must include the depth of discharge in it to be accurate, to make sure we are sizing the battery right, okay. So with this said, I think we have fully understand about all this, This is very, very important. These are the basic formulas you need, okay, when sizing your battery. This is important. So let's go into more like a practical aspect, a practical examples of how to size battery. So let's take some examples. Let me show you about these conversions we are talking about, and how you can convert different batteries to watt hour, or how you can convert from watt hour to amp or whatever. Let's take that for example. So take for example for lead acid batteries. You know, lead acid batteries always come, they will present to you the voltage of the battery, and also they will tell you the amperage of the battery. Okay, so how do you know the watt hour that a single tubular battery can produce? You are going to learn it from this example I'm going to share with you here now. Now take for example, what is the amount of energy a 12 volt 220 amps flooded or lead acid battery can deliver when fully charged? Let's say this is an exam. This is a mock exam for you now. How do you achieve this? It's simple. Okay, we are going to calculate the total the energy this battery can deliver. We are going to convert these amps and voltage, we are going to convert it to watt hour. Okay, after we convert it to watt hour, we apply a depth of discharge. You'll be able to know amount of energy a one tubular or dry cell battery can deliver to you. And here is how to go about it. So this is the battery formula we talked about earlier. We say if you want to calculate battery energy, you do battery amps times what? The voltage. In this case, they gave us the amps, they also give us the voltage. So it's simple. So if we do this now, it's going to be 220 amps times 12 volts. So every tubular battery you see rated 12 volts, 220 amps can deliver 2640 watt hour. So this is the total energy capacity of one tubular battery. But how many energy can it deliver? When it comes to deliver, that is where you now apply that depth of charge. Okay, so this is really how you get to know. You apply that depth of charge. So that depth of charge is 50%. So if you apply this 50% on this battery now, so the total energy 2640 watt hour times 0.5, which is 50% depth of discharge, we are getting 1320 watt hour, approximately 1.3 kilowatt hour. So whenever you are working with one tubular battery, be rest assured that the energy is designed Headley can give out is 1.3 kilowatt hour, but the total energy inbuilt on that battery is about 2640 watt hour. Okay, so with this now, you can determine how many tubular batteries can make up or can deliver equivalent power to 10 a particular size of lithium battery. Okay, with this calculation. So basically this is for calculation on lead acid batteries and all that. I hope it's clear. Just times, use the formula. After everything, you add of discharge, you'll be able to get amount of energy that battery can be able to deliver. Okay, so let's also look at another example now coming from lithium battery. So let's say for example, what is the amount of energy a 51 volt 300 amps lithium battery can deliver when fully charged? So let's also take the same example. The same formula, battery energy formula is battery energy in watts equals to battery amps times voltage. Okay, battery voltage. So if you do this, the battery amp is equals to 300 amps, right? If you times it by the voltage, so the total energy this lithium battery, a lithium battery rated this capacity, the total energy it can deliver, the total energy it has, the total energy it embodies is about 15,300 watt hour energy. But what is the amount of energy that can be possibly delivered, that can be possibly drawn from that device? And all you need to do is to apply the depth of discharge. Okay, what is the depth of discharge? The depth of how that battery can discharge, which is 0.8 for lithium batteries. Generally used, a lot of people say 0.9, a lot of people say 100%. But in all this, you need to work with your battery specifications. Some battery will tell you that their battery can, they will specify how the in-depth of their discharge and also their charging. Okay, but generally 0.8 is best used for lithium battery. And if you do that calculation, so whenever you see a 15 kilowatt lithium battery, okay, just know that it will not deliver the full 15 kilowatt. It can deliver up to 12 kilowatts. Okay, so this is how you go about ascertaining all this data, which is very, very important. As we are working now, you see that our daily load is on kilowatt, okay, our daily load is on kilowatt, not on amps or not on voltage, is on kilowatt. So we needed to convert this. If you are going to be sizing battery, we need to, whatever battery we want to size, we needed to convert it to kilowatt, and this is what we have done. All right, this is what we have done here. So now let's go ahead and size our battery. So what you need to understand is that to size a battery is not actually that hard. It's a very simple process, okay? But I needed to explain all these concepts about the battery capacity and all that, because very, very essential, because generally these questions about sizing battery and all that can come in different angles. So if you don't understand all these explanations about amps, voltage, watt hour, how to convert them, you will actually get it wrong. So now let's take an example. So for example, let's say they gave you an equation or list, a mock exam, like what is the capacity of 48 volts lithium battery needed to power a 12,450 watt hour daily load for 1 day. Okay, for 1 day. You see, it's specified. We are only calculating for only 1 day, and our daily load, based on our load assessment we did earlier on previous lesson, we got 12,450. This is what we need, the capacity of battery we need to keep all appliances and everything running for a day, based on the hours they are going to run and based on the numbers of device. Okay, so if we want to do this now, if we want to apply a battery sizing formula to get our battery capacity that will be suitable for this design, so we have to apply the battery sizing formula, which is, for you to calculate daily load, all you need is your daily load times backup days. Okay, so if we do this now, we also need to take note that what we are calculating for here is lithium battery. Different battery has different approach to it. So we are calculating for lithium battery, and here our battery voltage is actually 48 volts. Okay, so all these things has to be specified. We really need all this data to proceed to getting the right data. Okay, so now how do we get the amount of capacity of battery that can power this load for a day? And this is the simple formula. Our daily load here is 12,450 watts times 1 day. So this is the amount of battery capacity that can power this system for a day. As simple as that. But then, if you are going to supply now, we are not going to supply this. If you supply this, you will not be able to meet up this capacity. So that's why you need to apply depth of discharge. So on this being lithium battery, if we apply a depth of discharge of 80%, okay, whatever type of lithium battery you bring is always going to discharge up to 80%. So if we take that into consideration, okay, not to miss out on any energy, not to downsize the system or whatever, we apply our depth of discharge, which is 80%. So if you do an 80% on calculation, if you add an extra 20% calculation on this, our total capacity, our total battery capacity, add 20% to complement this 80%. So if you do this 12,450 watts divided by 0.8, which is less than, this is more like you are adding 20% to this calculation. So you are going to be getting 15,562 watt hour battery. This is approximately 15.5 kilowatt watt hour battery. Okay, so if you get the size of this battery, be rest assured that it can be able to power this system for a day, because at the end of the day it's going to discharge to 80%, and if it discharges to 80%, it's going to be delivering this amount. Okay, so that is the deal on how to calculate this. Now, what if you want to get, okay, what is the the total amp of this battery capacity that you can get? Maybe you are going to be searching for the battery with amp. So what is the total amp of battery that can make up this capacity, of which we have done before with the information? So our required battery energy is what? 15,560 watt hour. So if you now required amp now is going to be divided by 48. We have done this formula, is there before, how to calculate all these things. That's why I shared all those formula for us to be able to do this rightly. So if you divide the total watt hour of the battery capacity, divide it by 48, okay, you'll be getting. So if you go to market, this is what you are going to be looking at. You are going to be looking for a battery that is rated at 324 amps, 48 volts. Once you get this battery, you will definitely be able to get a battery that will discharge this amount of energy, which is 12,450 watts, which is our daily load. As simple as that. Okay, so on this now, you might actually not get a single battery that has 324 amps, and at this now you can actually approximate this, because you might not really get exact battery with these amps, but you can approximate it to 350 amps. But let's say you did not get a battery that can supply 350 amps, you might decide to, so you might decide I will go for 2 lithium batteries or 3 lithium batteries. Okay, but all you need to do then is that you have to maintain the voltage. The voltage has to be 48. Okay, then you divide, if it's 2 lithium battery you are going to go, divide 2 by this 344 amps. That means 2 divided by this, you'll be getting 162 amps. So you are going to be looking for a battery 48 volts, 162 amps. I mean, if you divide this by 2, you'll be getting 162 amps. So if you're going to get 162 amps into 2. So if you are going to go for battery to make up this, okay, you'll be getting 48 volt battery with 162 amps, 2 pieces. If you are going for one, you are going to go for 48 volt battery, 1 pieces, but the amps is going to be 324 amps. So if you are going for 3 battery, the same thing, you divide the numbers of battery you are going for with your total amps, but the voltage has to remain constant. It has to be that same voltage, 48 volts. Because okay, so basically that is how you ascertain your battery size. That is how you calculate a battery size that can power a particular load demand. Okay, now this is for lithium battery. Now let's take an example of lead acid battery, how you can go about that. Now let's say we have a question that's okay, what is the amount of 12 volt lead acid battery energy needed to power a 12,450 watt daily load times 1 day? It's the same question, but now we want to calculate it for different type of battery, which is lead acid battery, and our formula still remain the same. Okay, your battery energy needed is always your daily load times your backup days. Okay, so it's good to note the type of battery you are working with. So here we are working with lead acid battery, and the nominal voltage of most lead acid battery is 12 volts. So you need to put that into consideration. Now it's no longer 24 volts. I mean, it's no longer 48 volts, it's 12 volts. But we are still going to work with it to ascertain the amount of battery capacity we need in terms of lead acid battery. So this is the basic information we need to conduct our calculation. So if you are doing this now, same thing, you do your daily calculations. Remember this one here, if we are calculating battery needed for 2 days, it's going to be times 2, because we have 1 day here. That is why we have 1 day. So if it's 2 days, we are going to do this times 2. 3 days times 3. Okay, so our daily energy based on our calculation, based on the days we are powering, is 12,450 watts. Okay, now we apply depth of discharge. Like I said earlier, depth of discharge for lead acid batteries are 50%. So if we apply depth of discharge for this, we are going to be getting 12,450 kilowatt hour divided by 5 to add it up. This is more like times 2 of this. Okay, so if you do this, it's going to give you, so this is the total, our battery bank, the total energy inside our battery bank should be 24,900 kilowatts, 900 watt hour energy. That is what should be total energy of our battery bank with lead acid battery. And this is because we have in mind that we will have this as our total energy bank, but this is the recommended amount we can discharge from this battery, which is up to our daily load. Okay, so we are still in, even though we have a lot number of watt hour energy bank, this is the amount we are expected to discharge from the battery, which keeps us cool, which makes our calculation very okay to power the system, okay, to meet the daily energy demand of that home. Okay, but now how do we determine numbers of tubular batteries that we need? How do we determine numbers of lead acid batteries that we need? That is the next thing. So actually the total required battery needed, energy of battery we need. So how do we determine the numbers of tubular? First of all, we need to know the total amps of battery we need, and this is how you go about it. So we have done this formula is there, how to calculate battery amps when you are giving watt hour and the voltage. In this case now we have the watt hour, then we also have the voltage, but we don't know the amps of battery, the capacity, the capacity of the battery we need. We don't know the amps of we need, and to do that we do our what, our total wattage of the battery divided by the battery voltage. So what we are looking for in terms of tubular batteries, we are looking for total of 2750 amps capacity of tubular batteries. That is what is going to be enough to produce this watt energy and also be able to discharge up to this amount. So in this case now, if we want to get the numbers of tubular batteries we need, so what we are going to do here is that we are going to do what, the required amps divided by battery amps. So what this means, the required amps here is 2750. Now the battery amps now will now depend on you. What type of tubular battery do you want to use? Every tubular battery is rated in amps. The voltage is always 12 volt and all that, but then the amps, they must tell you what amps it is. Most on-top tubular batteries, they are rated 150 amps, 200 amps, 220 amps, 240 amps, 250 amps. You see them on that ground. So on this ground now, if you want to know what is the numbers of tubular battery I need for this, you need to get an idea of what is the battery amps, what is the amps of the tubular battery you want to use for this system. If you get the battery amps you want to use for this system, you'll be able to get the how many pieces of the battery you will need to make up these required amps. Okay, so if you do it that way, it's going to be required amps, which is 2750 amps, divided by the battery amps you want to use. The battery amps you want to, they are selling, what is the amps? In my own case, we can use 220 amps, which is the one regularly used here. Okay, so let's say for example our battery amps is 220 amps. So if you do it that way, our required amp is 2750. Then the battery amps we are going to use for this system setup is 220 amps. So if we divide this 220 amp by this 250, you see that we are getting about 9.4 pieces, okay, of tubular batteries, approximately 10 tubular batteries. That is what is going to make up for this system, for this. So that is what is going to make up for this required amps we need to power this daily load. And as you can see, 10 pieces of battery. But then when you are using dry cell batteries and all that, and third tubular battery, you need to consider your connections. Okay, your connections matters, because our system is 48 volts, but our battery is what, 12 volts. So for us to be able to get 48 volts, we'll be needing 4 pieces of this battery. 4 pieces of this battery can give us 48 volts. 4 pieces of this tubular battery we have here can give us 48 volts. So in this regard, if you do a calculation of this, you need to actually align your battery size to be able to fit into your connections. That's just what I want to say. So if I'm to do this kind of battery sizing now, I will have to recommend 12 pieces of tubular battery here instead of 10. Okay, 10 gave us the appropriate capacity we need that can power the system. But if we analyze it down to how we are going to connect it, 10 is not going to fit in. Okay, so we are going to do like 12, because if we series 4 batteries, we'll get 48. So we can do 4 into 3, then parallel the 3. We do 4 series, plus and minus into 4, we'll get 48. We'll do another one, plus and minus into 4, we'll get 48. Do another one, plus and minus, we'll get 48. You see that it has now total to 12 pieces of tubular batteries. Then we'll now parallel them. We'll join them up so that they will all maintain that same 48 volt system. So if you look at it that way, you see that the total number of batteries we'll be needing to make this possible is 12. So we can decide to go for 8. 8 will make our estimation here low. It's not going to meet up to our daily energy need. So is it better to leave it at the higher side, which is going to be like what, 12 pieces of tubular batteries. That is going to be need to be able to not only supply this energy, 12,450 watt daily energy, but also fit into our system connections. Okay, so basically that is sizing battery. So if you look at all these things I've explained here, you see that there is not actually much thing here needed. Just understand how to do these battery conversions, and just know that to calculate your battery size, your total daily energy, you just apply your depth of charge, you'll be able to know the exact capacity of battery you need to power that load. That is it. So when it comes to the numbers of batteries you need and all that, that is where all this calculation will come in, okay, for you to determine the numbers of battery, whether in tubulars or in lithium battery. You can break down the amps, okay, you can break down the amps to get your total numbers of battery you need to power a system, okay. So this is it. That is it about sizing your battery. So I know this thing can be a little bit technical, but if you take your time, you can rewatch this video multiple times for this thing to sink. Once you get them right, okay, this work become more easier for you. You will now be able to be proud. You'll be able to pride yourself as a solar engineer, because you'll be able to handle a lot of questions. You'll also be able to troubleshoot issues in any solar system. So understanding this sizing and designing aspect of solar system is very essential, and that's why I'm taking time to explain them to the details. So take your time. If you miss re-watching all of this module, starting from load analysis down to the last lesson in this module, just to make sure you understand this aspect of system sizing and design, very essential, okay. So basically that is it about sizing your battery. I hope it's clear enough. If you have questions, you can use the available options to ask your questions. I'll be glad to attend to them, okay. I'll see you in the next one. Bye for now.